This video should give you a quick overview of how to solve quadratic equations using three different methods. The first method is solving a quadratic equation by factoring it. And in order to solve a quadratic equation by factoring, you first need to move everything onto one side of the equation. A good rule of thumb is that the x squared term should be positive, and so the fact that it's already positive over here means that I'm going to move these two things over to the left side to keep that term positive. Now when I say move them, I mean to get rid of a negative 36 over here, I would add 36 on both sides. And to get rid of a minus 15x, I would add 15x onto both sides. Now you'll notice kind of the way I wrote these over to the side rather than writing them directly under the x squared term. That's just as a reminder that none of these are going to combine. But over here, negative 36 plus 36 makes 0, negative 15x plus 15x makes 0, and over here I'm going to write these in a standard form order, meaning x squared first, then plus 15x, then plus 36. Now that I have everything on one side, I can factor this quadratic trinomial. You may remember using our little x game. Since there's no coefficient in front of the x squared, or it's a 1, that means the positive 36 is what goes up top in our x game. The positive 15 is what goes in the bottom. And so I'm looking for two numbers that will multiply to make 36, but add to make 15. If you don't know them off the top of your head, that's fine. Just start by listing factors of 36, and hopefully eventually you'll find the right pair, which I think right here it would be, because both of these, the c term and the b term, are positive, which means both of the factors are positive, and 3 and 12 are the ones that add to make 15. So I drop these numbers into my parentheses over here to get the factors of x plus 3 and x plus 12. Now that I've found that these are the two factors, the zero property of multiplication says that if you are going to multiply two terms and get a product of 0, that means one or both of the terms themselves must be equal to 0. And so we consider x plus 3. What if that's the one that equals 0? What value of x would that be? And we consider the x plus 12 being equal to 0. In this situation, what would x be? In doing this, we find the two solutions to the original quadratic equation. And so in this case, this little equation would be solved by subtracting 3 on both sides so that x is by itself. And so we get x equals negative 3. And over here, I would have to subtract 12 to get x by itself. So I'd get that x equals negative 12. So these two values for x are the only two values that would make this original quadratic equation true. And you can write them out like this by listing the first one, comma, the second one. Or really, you could just leave them separated and circle both answers to let me know that those are your final answers. The second method that we're going to look at for solving a quadratic equation is known as the square roots method. In order to use the square roots method, there has to be no b term in the equation, and by that I mean the a term is the one attached to the x squared. The number or numbers that don't have variables attached, those are c. It's the one that's typically attached to just an x that's considered the b term, and you'll notice in this case there isn't one. When there isn't a b term, that lets us know we can use this square roots method. And the first step is to isolate the x squared variable. I do that first by adding this 3 onto the other side to get rid of the minus 3. And so I have 5x squared is equal to 360. Then I would divide both sides by 5 to get that x squared is equal to 72. Now that I have the x squared term by itself, we can kind of take it a step further to say I don't really want to know what x squared is equal to. I would like to know what just x is equal to. And so essentially we're going to try to undo this exponent of 2. Well, the way to undo something that has been squared is by taking its square root. A square and a square root cancel, leaving me with just x, but I had to do the square root on both sides of the equation to keep everything balanced. So that would give me the square root of 72, which we can talk about in just a second. But remember that a quadratic equation typically has two solutions and not one. The way that you get two solutions from using the square roots method is by remembering that technically in algebra, when you take the square root of a number, you shouldn't just get a positive answer as your number. You should get a positive and a negative. And so when you're using the square roots method, if you remember to put the plus and minus symbol in front of your answer, that indicates that it's not just the positive answer, it's also the negative. And so those are your two answers to that equation. Now back to the square root of 72. The square root of 72 is not perfect, meaning it doesn't give us a whole number answer, but in our last unit we learned how to simplify square roots like this. I could break this down to be 8 times 9, and 8 would break down to be 2 and 4. 2 is prime, but 4 breaks down to be 2 and 2. 9 breaks down to be 3 and 3. So remember, you list out all of these prime factors that you underlined, list them out in order underneath one radical symbol, and then look for any pairs that you see, which I find a pair here and a pair here. A pair on the inside becomes just one on the outside. Whatever I'm left with stays under the radical. Put this together and you get 6 square root 2. So my final simplified answer here is not just the positive or negative square root of 72. It is a positive or negative of 6 square root 2. This is considered your simplified answer. And again, note that this does represent two solutions, not just one. It's basically another way of saying that the answer is 6 square root 2 and negative 6 square root 2. Writing it with the plus or minus symbol in front denotes both answers at once. The last method I'm going to show you for solving a quadratic equation is by using what's known as the quadratic formula. This one is a favorite just because it works for any quadratic equation, but my warning on this is that the quadratic formula can be pretty tricky and it's easy to make mistakes, so I kind of use it as a last resort. If I can't factor the equation, if I can't use the square roots method, then I'll use the quadratic formula. The quadratic formula is something that you don't necessarily need to have memorized. It would be listed out on a formula sheet for a test that you would be taking. You just have to be able to get it from the formula sheet. And it says x equals negative b. Sorry about that. X equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So again, I think with this you can probably see why I say it's a good one in that it works every single time, but it's bad in that it's a really complicated formula. But before you can even think about using this formula, you have to first take the quadratic equation and move everything in it onto one side. Now again, just as a rule of thumb, I like to keep the squared term positive, so since it's already positive over here, I'm going to move the 6 and the 5 in to the other side to join it. I'm going to just recopy the problem over here so I have a little more room to work. So again, I'm going to get rid of the 6 by subtracting it on both sides. I'm also going to get rid of the 5 in by subtracting it on both sides. Notice that I write the minus 5 in underneath the plus 3 in because those are like terms. They will combine. And now in my answer, I'm going to put the 2 into the second first because this is going to be standard form. This would now be a minus 2 in. And lastly, I put the minus 6. And all of this is equal to 0. Once you have everything on the same side of the equation, you next need to identify your values for A and for B and for C, because those are the numbers that we need to plug into this formula over here. A is always the number that's multiplied by x squared, so in this case it's a positive 2. B is always the number that's multiplied by just x, so in this case that's a negative 2. And C is always the number that has no variable attached, so in this case it's a negative 6. Once you've identified A, B, and C, you can plug them into their appropriate places in this quadratic formula. Note that this negative b doesn't actually mean a negative number. It really means take the opposite of whatever b is. So in this case, b is a negative 2, so the opposite of that would actually be positive 2, plus or minus the square root of, instead of b squared, I say negative 2 squared, and then I'm going to say minus 4, instead of a, I multiply by 2, instead of c, I multiply by negative 6, and all of that is going to be over 2 times 2 in this case. Now that can seem a little overwhelming when you see it written out like this, and the temptation is to try to put all of this into the calculator, but there's just so much that can go wrong with the order of operations here that I really don't recommend doing that. After you've written it out with the numbers plugged in, my recommendation is to work out just this inside part of the radical. Don't even think about the square root yet, just figure out what that inside number would be. And so if I put all that into the calculator, I should get x equals 2 plus or minus, again, just doing what was inside here, that came out to be 100, divided by, I can go ahead and say here that 2 times 2 makes 4. So again, I just figure out what this stuff would be. In this case, I get it to be 100. And then I expand my thinking a little bit to say, okay, what is the square root of 100? In this case, that actually is a perfect square root, so I can rewrite this to be 2 plus or minus 10, because that's what the square root of 100 equals. Again, all of that's supposed to be divided by 4. From here, to get your two answers, you need to kind of separate the formula, once with the plus and once with the minus. So consider first 2 plus 10 divided by 4, then consider 2 minus 10 divided by 4. Figure out what 2 plus 10 is. In that case, it makes 12. Then divide that by 4, and so you would get 3 for your first solution. Over here, figure out what 2 minus 10 is. In that case, it's a negative 8. Then divide by 4, so that gives me a negative 2. So all of this work has now led me to say the two solutions to this quadratic equation are a negative 2 and a positive 3. And that's the third method that we can use for solving quadratic equations.